Hello and welcome to Career Talk by Shubham Pathak, and this is the second lecture of the series for electronic devices. And the topic for this lecture is what is thermodynamic equilibrium and steady state. So, thermodynamic equilibrium. Thermodynamic equilibrium. So, to understand this, first you need to know what is equilibrium, right? So, a system or a semiconductor. In general, if we talk about equilibrium, then we can say that if there is a system, later on we replace the system by semiconductor. A system is said to be in thermal equilibrium. With respect to what? With respect to environment. So with environment. If now focus, this condition is important. If any process that takes place in system, right, exactly same process or reverse process, must take place. Right? So if there is a process in which some amount of heat energy is dissipated, then there should be exactly reverse process in which that same amount of heat energy is absorbed. So as a result, there will be no net energy, no net change in energy. There will be no net change in energy, right? And the system is in equilibrium. So if we talk about in the context of semiconductors, then the semiconductors is in thermal equilibrium only if there are two conditions for semiconductor to be in thermal equilibrium. First is no external excitation except temperature. Right? So temperature can be the external excitation, because we are talking about thermal equilibrium, right? If there would be some other sort of external excitation, then our system or semiconductor will not be in thermal equilibrium, right? Okay, so no net motion of energy. So this second condition will be ensured by this, that there should be exactly reverse process, right? If there would be a reverse process, then no net change in energy will be there. So if let's talk about now then non-equilibrium condition. What would be non-equilibrium conditions? So non-equilibrium condition. Let's suppose there is a system, there is a body. This surface temperature has T1, this surface temperature has T2. Okay, and T1 is greater than T2. So there will be temperature gradient. There is temperature gradient. Gradient means slope. So there will be a difference in the temperature of the two surface. So when there is a temperature difference, then obviously one portion has high amount of heat energy and the second portion has less amount of heat energy. So energy starts flowing from high concentration to low concentration, from high concentration to low concentration. So there is a net change of energy, right? So that's why it is not equilibrium condition. Second example you can take, let's say there is a system and if light falls upon it, okay, so if light falls upon it, its temperature increases, its energy increases. Energy increases. If energy increases, it implies that temperature also increases. But there will be no reverse process to reduce that temperature to the initial one. So that's why it is not in an equilibrium condition. Now further, I will talk about steady state. What is steady state? Okay. So if there is a system S, right, all process takes place within that system, right, are constant with respect to time. अगर सारे प्रोसेस टाइम के साथ कांस्टेंट हैं तो हम उसको स्टेडी स्टेट कहेंगे. एंड देयर इज नो नीड फॉर रिवर्स प्रोसेस, नो नीड फॉर रिवर्स प्रोसेस. Why there is no need for reverse process? Because if there would be no exchange of energy, right, no change in the energy, exchange of energy, then what is the requirement of reverse process? When we were talking about equilibrium condition, then there is a process which undergoes some sort of energy change. So we require exactly reverse process to undergo an energy change which is exactly opposite to the previous process, right? If some process dissipates his heat energy, then we need a reverse process which gains the same amount of heat energy to compensate that. So to ascertain that there would be no net change of energy. But in a steady state, if process is constant with respect to time, so over the period of time we won't notice any change of energy in that system. So exactly reverse process is not required. All processes which are independent of each other, if we observe that over the period of time there will be no change in that process, then obviously there will not be any change in the heat energy. So the system would be said to be in a steady state. So I hope you have understood that what is thermal equilibrium and what is steady state for a semiconductor. We can replace that system with semiconductor, right? Because it is in general definition for steady state and semiconductor. Thank you very much.